Hi, this is Carter with Fifth Floor Gaming. Last April, I participated in my first ever game jam and also made my first ever game in Unity. The theme of the jam was dreamy, and a limitation that was chosen was every playthrough must be unique. Taking this idea and limitation, I made the game Sleepy Sheep. It's a game where you play as a boy trying to fall asleep by counting 10 sheep. You run around in the darkness with a flashlight, trying to find sheep hidden throughout the map. When first thinking of ideas for the game jam, I immediately knew that I wanted the map to be random and the sheep to change locations on each playthrough. Admittedly, this isn't a very good game, and I've grown immensely since creating it. In this video, I would like to explore how I made the game and discuss things that I would change now that I'm much more experienced with both Unity and game development in general. I'm a professional developer in my day job, so I'm fairly well acquainted with how to break down a big problem into smaller parts, and I approach this game pretty much the same way. I broke the game into a few categories: player movement, how to keep score, and then the big one, procedurally generated maps and sheep locations. I've gotten a lot better at it recently, but I'm not a very good artist, so I didn't really plan for art or music ahead of time. The first problem I tackled was getting the player moving. I drew up my character in Sprite, imported the sprite into Unity, and created a 2D sprite renderer. I gave it a circle collider, a rigid body component, and wrote a script to control the movement. The movement code is pretty simple, and I would almost never write this now, but I guess it works well enough. I have one function which checks if the player is pressing WASD or some combination of those buttons, multiplies that by set speed, and then adds that value to the player's current location. Looking back, since I'm doing movement this way, there's probably no need for the rigid body component, and I'm probably just wasting CPU cycles. At this point, I figured the game is probably going to be too simple and not very fun, so I decided to add a flashlight mechanic. Unity is pretty good at 2D lighting, so this was also pretty easy to get working. I added a freeform 2D light attached to the front of the player in the rough shape of a flashlight, and then wrote some more code. This code gets the player's mouse position and then draws a ray to the character. It then takes points on that ray, converts the Cartesian point to a polar angle, and rotates the character to look at that point at all times. My code does this Cartesian to polar angle conversion manually, because at the time I didn't know that Unity has built-in functions to calculate the angle between 2 points. And with that, the flashlight is done. Because the flashlight is attached to the player, when the player rotates, the flashlight also moves. I slapped on a 2-frame walking animation, and my character was pretty much done. With movement working good enough, I decided to move on to try to find some way to keep score. I wanted the score to count up every time you collected a sheep, so that the player knew how many sheep were remaining. If I had to do this again, I probably would have it count down rather than up. It seems to make more sense from a game design perspective. Getting the sheep to increment a score was pretty easy. I put the sheep in a prefab with a 2D capsule collider and then wrote a small function to increment a counter in the game controller every time a sheep was touched. I really like the idea of having separate controllers for the high-level logic in my games, and continue to put game controllers in Unity games that I make now. One thing that I've learned since making this game is that I absolutely love Unity events. Rather than make each sheep have to know about the game manager, I probably would implement this with an event invoked by each sheep and a listener in the game manager if I was going to remake it. At this point, I realized something. Since I don't have any map generation, and I don't even know what that'll look like yet, I don't know where to actually place the sheep. So I abandoned the sheep until the map stuff was figured out, and we'll talk more about sheep placement in a bit. For the procedural maps, I explored a few different ideas. I thought of randomly placing different sized square rooms, and then connecting those rooms with hallways. I also explored the idea of creating mazes using Prim's algorithm. And finally, I landed on using a random walk algorithm, because it gave the game a more cavern, underground type feeling. If you aren't familiar with the random walk algorithm, it generally works like this. First, divide your map into a grid, then pick a random point on that grid and set it active. That point is allowed to walk randomly, either north, south, east, or west. For this example, let's go north and set that point active. Then that grid point does the same thing, so let's go west. This continues until you either walk yourself into a corner that you can't get out of, or after a set number of steps. Then you throw away all the spaces that aren't active and leave the rest. This gives you an interesting shaped map where all the spaces are connected. Let's look at some code. This isn't a great method of doing this, but hey, it was a jam and I had limited time, and I needed to make sure that it worked right the first time without too much debugging. This code works like this. I took a number of steps based on a walk depth. This was an arbitrarily chosen number that picked maps of a good size without too many twists and turns. Then, like our example, I stepped around the grid activating squares. Unlike our example, my algorithm also moves diagonally, since in a 2D game you can definitely squeeze through those diagonal spaces. I ran into a bit of a problem determining which tile for my tile map I needed for each space. I made a function called getNeighborCount that counts how many tiles near a space are active, and used that to determine if you need a ground tile, left wall, right wall, etc. I then went back and fixed my sheep. I used the game controller to instantiate sheep prefabs on only spaces that I know are active, and also floor tiles. I didn't want those sheep stuck in walls where you can't actually catch them. From this point, all I had left to do was to create a main menu, a win screen, and then upload the game to itch. Like I said at the beginning of the video, this game didn't place too well in the jam, but that's okay. I had a lot of fun making the game, and I don't think it was too bad considering it was my first game jam and the first time using Unity. I think it was technically strong, but lacking good art, good polish, and could have benefited from a more interesting core game loop. If you'd like to play this game, I'll have a link in the description of the video. Fifth Floor Gaming is a small collective of game developers, and we're currently working on a larger turn-based multiplayer game called Hexane. We plan to have more videos on this channel in the future going over some of our other small projects and the interesting parts of Hexane as we work on them. Thanks for watching.